All right, so last video we learned a little bit about logarithms in general, and we said that it's kind of a way of rewriting in exponential form. You're asking yourself that question of what power. So today we're going to do some work to link logarithms and exponentials through the process of inverses. So our warm-up says to plot the key features of the exponential graph 2 to the x. So if we remember, our points that we go through are going to be 0, 1, and 1 base. So 0, 1, and then 1, our base here is 2. Our horizontal asymptote is y equals 0 because there has been no shift, right? This is one of our parent graphs. Our domain then is all real numbers, and our range will be everything above that horizontal asymptote. So again, this is a review of graphing an exponential function. If you need more review on that, you can go back to stuff in previous folders. Okay, so now it says use the properties of inverses to graph f of x equals log base 2 of x. So if we think about some similarities here, we still have a base of 2 that's going on, and we still have our x. If we're going to use inverses, remember the first step to finding an inverse is to switch x and y. So on the other one, we had the point 0, 1, which means if I switch my x and y, I'm going to have the point 1, 0. On the other one, because we had a base of 2, we went through the point 1, 2. Here I'm going to go through the point 2, 1. So 1, 0, 2, 1. Before I had a horizontal asymptote of y equals 0, but I'm supposed to switch my x's with y's. So now I'm going to have a vertical asymptote. Right? Instead of horizontal, we now go vertical because we're switching x and y of x equals 0. So now my domain, which is usually the x values, right, is 0 to infinity, my previous y values. And the range, which is the y value, will be my previous x values. So all I'm doing again is switching everything that related to x and y that was listed above for our exponential that had a base of 2. And so our graph ends up looking like this. Okay, you don't have to draw this next part in, but I'm just going to show you. Our other graph that we had for our exponential went like this. And what we did is we reflected over the line y equals x, right? If you put a mirror on that line y equals x, this graph has just been reflected over. But again, you just have to draw in the green there. All right, so a reminder of our properties of logs. This was at the end of the last video. Log base b of 1 is 0. Log base b of b is 1. We went through the point 1, comma 0, and we went through the point base, comma 1. Log base b of b to the x, since these are inverses, they're going to cancel, and we're left with x. B, the base of an exponent, when your log appears in the exponent, those are inverses, they'll cancel, and we're left with x. And then remember, if log base b of x is equal to log base b of y, then what has to be true is that our arguments, x and y, must be equal. Okay, so that's a nice little review from the last video. We're going to use that a little bit today. Anytime you see log without a base, so if you just see log without like a little 2 or a little 3 or a little 8, look at all that fun number changing I did. If you just see the word log, that really means a base 10. It's what we call the common log. And that's important because it's a button on your calculator that you can use without needing that change of base formula. When you see ln, this is what we call a natural log. And really what it means is log with a base of e. Okay? So log with a base of e. But as mathematicians, we don't write log with a base e. We instead write ln. So you'll see things like the ln of 7, which really means the natural log of 7, which is again a button on your calculator that you can use. So we're going to try to simplify these using the properties of logarithms that were listed above. I'm going to go through and do 1 or 2 and then have you try some on your own. So log, there's no base here, so it's understood that there's a base 10. Log 10 of 10, well, those are inverses, so they'll cancel, and I'm left with just 3x. This one, e to the natural log of 4x, Well, natural log really means log with a base e. So these are now inverses, and I'm left with 4x. Okay, go ahead and see if you can try B and C. Pause your video and then come back and check. All right, hopefully this is what you got. So 10 with a base in the exponent raised to log in the exponent are going to cancel as inverses, and we get x squared. This one, the natural log, remember that really means log with a base e of e to the x. These are inverses, so we're left with just x. These next ones are a little bit trickier. This is a log with a base 10, but this is not 10, so these won't just cancel. We're going to have to do a little bit of rewriting. So I'm going to do this as log base 10, and I'm going to write 100 as 10 to the second power using my power book. So now log base 10 of 10, those are inverses, and we're left with just 2. This one again, log base 5 of 25. We need to rewrite this 25 as a base of 5. So using my power book, I could rewrite this as 5 squared to the x, so 5 to the 2x. Now these are inverses, so we're left with just 2x. Okay, there's more of these that are going to be in your practice and big ideas. So make sure you understand all I'm doing is applying this property and this property, are really the ones that are coming into play here. All right, next section says find the inverse for each equation by switching x and y and then solving for y. Remember, those are our steps for finding the inverse. So I want you to try 1 through 6 on your own. You're going to switch your x and your y and then solve for y. Okay, so go ahead and try those. Pause your video. Come back when you're ready. Okay, so these two in blue are going to relate with each other. This started as x adding 2 is equal to y. So when we find the inverse, we end up with x subtracting 2 is equal to y, because addition and subtraction are inverse operations. Same thing here, we started with subtraction, and we end up with addition because of the inverse relationship. For 3 and 4, we're undoing multiplication, and then we are undoing division. So when we undo multiplication, we have a result of division. When we undo division, we have a result of multiplication. 5 and 6 combined together, talking about squaring a value versus taking a square root of a value. Those are inverses. The stuff that I wrote over here, okay, are small caveats that are important in the domain and range of these things, but I'm not really worried about it for today's lesson. When you take the square root of x squared, you should have the plus minus. That's going to be important. And then for this one, technically you only end up with the positive square root, but not something we need to worry about for this class. So these next ones are the new ones, okay? And the only reason why these are a little scarier is just because they're new, but the same process is going to apply. So I'm going to switch my x and my y, and then I need to solve for y. Well, the way that you solve for y would be to cancel out this 2 that's an exponential. So to do that, I'm going to use those properties of exponents with logs to get our inverses to cancel out. So now, if I do log base 2 of the left side, I've got to do log base 2 of the right side. Log base 2 is going to cancel out with the 2, and I'll just get y equals log base 2 of x. So there's my inverse. Okay, for this next one, I'm going to switch my x and my y around. So I'm going to have log base 2 of y equals x. And this time, I don't need to get rid of a 2 as the base of an exponential. I need to get rid of a log base 2. So I'm going to use exponents to do that, because an exponent is the inverse of a logarithm. So I'm using a 2 so that my 2 and log base 2 will cancel out, and I'm left with y equals 2 to the x as my inverse. Okay, so really what you're doing is you're just finding the inverse operation. Just like, for instance, number 3, okay, I did 2y divided by 2 in order to get y by itself. Okay, so I'm using the inverse in order to isolate the y. All right, so these ones are a little bit more challenging just because they have the adjustments within the graphs. So for instance, this one would have been shifted to the right 7, this one would have been shifted to the right 4, but we're still going to use our same properties to find the inverses. So to start to find an inverse, we're going to switch our x and our y. And now I need to do some work to get y by itself. So remember, this is really a base 10. So I'm going to use an exponential of 10 on both sides. Because now on the right side, my 10 and my log will cancel. And now all I need to do is add 7 to both sides. So 10 to the x plus 7 is my inverse of this original equation. Okay, next one. Again, I'm going to start by switching my x and my y. This time I need to get rid of an exponential. Well, to get rid of an exponential, I need to use a log of both sides. So I'm going to take the log of a base 10 on both the left and the right. So I'll get log of x equals log and 10 are going to cancel, y minus 4, and then I'm going to just add 4 to the other side in order to get my y isolated. Okay, so this was an exponential shifted to the right 4. This is now a logarithm shifted up 4 because we're switching our x's and our y's, so our direction of movement. All right, this next one, switch x and y. Oops, that was not a log. That should be a natural log. All right, so I'm trying to get my y by itself, but notice that this time I have the plus 2 on the outside. So I'm going to subtract 2 to get started. So I get that natural log all by itself, just like we would usually work to get the square root or the radical by itself. And now I'm going to use those properties of exponents. Remember, ln is natural log, which is really just a base e. So I'm going to use an exponential on both sides that has a base of e. On the right side, e and ln will cancel. And we're left with this inverse. Last one, I'm going to switch the x and the y. Again, I notice that my exponential is not by itself yet. So just like when we want to isolate the radicals from our previous units, I'm going to do the subtract 1 first. And now I need to get rid of an exponential. Well, the way I get rid of an exponential, because the variable is stuck up here, is by using a log. And in this case, I want to use the natural log, so the ln. On the left side, I'm going to get the natural log of x minus 1. And on this side, logs and exponentials will cancel, and this becomes my inverse function. All right, so we have some big ideas practice for you to do on the website. But one important thing to think about or to remember is that a logarithm, whatever that base is, will undo an exponential, while an exponential will undo a logarithm. So we're using that properties of inverses to cancel things out. Make sure you jump on a Google Meet if you are feeling stuck at all, but you can go try your 5, I think there's maybe 8 questions today, and big ideas going over inverses.